Hello everyone. Hello everyone. And today I hope you can let me share my screen. And today we'll be covering how to perform time series forecasting using Tableau. Remember, you can do this using Excel or Python, but this session will focus on covering time series forecasting using Tableau. So let's open our time series data. So we go to text file, and it's a crime about areas or boroughs in London. And we have our data. Remember, the first thing you do when you want to perform time series is to check for the temporal element within the data. The first thing we can actually see that we have a column that captures crime, which is the total number of crimes for each borough or each area within London. We also have different categories of crime: burglary, drugs, robbery, sexual offenses, and other major categories. And for each of these boroughs or each of these areas, we have captured the total number of crimes for each month in a year. We see this is January 2018 for barking for this particular category, and so on and so forth. And this runs up to December 2018. So from January 2008 to December 2018. So we have that temporal element, which is our months and years across and from 2008 to 2018. So this data is suitable for time series forecasting. The second element is to check for consistency. What do we mean by consistency? The first thing about consistency is the length of the temporal aspect. In our case, we have monthly data from 2008 to 2018. That is a sufficient amount of data for us to be able to capture patterns, trends, and seasonality within the data if there are any. So if there are any trends, if any trends have occurred in terms of the way crime occurs within areas within London, 10 years is a large enough time for us to be able to capture this trend, or to capture if there are seasonal patterns, if there are some months where there is a peak amount of crime and some months where there is a low amount of crime, and this pattern repeats every year. So seasonal patterns within the data, that length is sufficient enough for us to capture the pattern. So, and our data clearly has a lot of data from 2018 to 2000, and from 2008 to 2018 monthly data is sufficient and enough data. Another aspect of consistency is, do we capture this data consistently over time? So for example, we capture this data monthly every year, so it is consistent. In another case, imagine we capture the data in January, and then we skipped February, then we capture the data in March, then we skipped maybe different months and capture the data in another month, and in other years we capture data in different months. So there is no consistent there's no consistency in the way the data was captured, right? We want data to be captured. Is it daily? Is it weekly? Is it monthly? Is it every 3 months? Is it every 4 months? But there should be some form of consistency in the way the data is captured, so that we can be able to actually identify these trends and patterns within the data. If there is no consistency, if the data is randomly captured in different months and there is no consistency, it is not suitable enough for time series forecasting. So that is the second thing about, sorry, that's the second thing about time series. And since we have been able to identify that we have enough data and our data is consistent, we can move forward to plot our time series forecast. The first thing about plotting time series forecast is choosing the right visualization, and the right visualization for time series forecast is a line graph. So let's plot our time series. So we have our year, we put in our columns so that it's in the x-axis. Remember, the columns falls in the x-axis, and we have our crime, we put in the y, so that we have our total number of crimes. But this now shows us as a bar chart, And if you go to show me, you see we can't actually highlight on the line graph for some reason. And the reason why Tableau has decided to plot this graph as a bar chart initially instead of a line graph, and has not been able to allow us to use the line graph, is because if you look at the data type of the year and the month, it's considered a categorical data type instead of a date data type. Remember, when you're dealing with time series forecasting, it's important that the feature, which is your temporal feature, is captured as a date feature. It could be months, it could be days, it could be years, but it has to be represented as a date feature and not a categorical feature. In our case, it's represented as categorical features. So you see A, B, C, and that's why Tableau has used a bar chart. Remember, a bar chart is very suitable for representing the distributions of categorical features. So let's change this categorical data type. So if we go to data type, change data type, let's change it from a string to a date data type. And you see that automatically Tableau now creates this line graph for us. So it's now suitable because now you see our our dates are now in a date format, and you see now our line graph where we can easily spot the trends and differences. But you see, we need to scroll, right, to be able to see the entire timeline. So let's go to standard, and we change the standard to entire view so that we see the entire timeline in one view, right? And we see that there is this downward trend and upward trend afterwards, but it's not very clear. So let's fix this. There is a lot of data here. So you see none of the crime, all the crimes, the total number of crimes starts after 50K. So it's good for us to fix our y-axis to start around 50K, right, instead of starting around 0, because there is no year where the total number of crime is below 50K. So there is no need for us to represent this information in this axis. So we click on this axis, we say edit axis, and we see include 0 in this axis. We do not want to include 0. And you see now it starts from the minimum amount of total crime, which makes our plot more bigger, clearer to see patterns, clearer to see seasonality within the data. And you can also change this to total crimes, the name, total crime. And we have that within. So we have our total crime. We can edit the axis. Sorry, not edit axis. We can go to formatting, and we just increase the font a little bit so that it's visual pleasing. And here as well, we will do format, and we'll just increase the fonts a little bit as well so that it's clear enough. And we see this downward trend up to about 2014, where crime rate within the city of London was decreasing over time. Then later, after 2014, we see this significant increase over time. So we actually see the trend. It's clear and visual, and you can clearly see the trend. You can even highlight on this part of the plot and say you want to add a trend line. But Tableau rejects. Tableau says typically each axis should either a number or a date. So Tableau is saying this is still not a date column, even though you remember we changed the axis to date. So we went to year, month, we changed the data type to date. It's still telling us it's not a date column. So how do we rectify this? We go now to where our column, our feature is. We have the year and the month. If we click on it, we see this. So if you click on the arrow, the downward facing arrow, you see again, even though it's taking the exact date, you can now choose what type of you can choose the format of the date we want to use. In our case, let's say we want to use the month and the year. Remember, our data was captured every month. We do not have weekly data. We do not have daily data. We have monthly data. So let's choose the month and the year. You see here, it says May 2015. So it will capture, it will represent the month and also the year in which the data was formatted. Just to tell Tableau that to emphasize, so we're trying to emphasize, even though we have changed it to date, Tableau still does not identify that it's date. So we want to emphasize that it's actually date. So we want to say, convert this to month and year of each date. And when we do that, it has converted that to month and year. If you highlight here, you see January 2018. You highlight here, you see March and so on and so. So it has converted to month and year. And let's try again. Let's see if we can capture the trend. And if we put, if we highlight on any point and we say trend lines, let's say show trend, and we now see that downward trend, right? That is the downward trend we are seeing. And again, if we highlight on this other part, you see it shows the upward trend. If you highlight on this part, it shows the downward trend. If you highlight any part you highlight on, so if you highlight from year to year, it shows that it's going upwards, it's going downwards. And if you do not highlight in anything, it says generally, considering how downward it was going and how odd and how it has been increasing, generally there is still the downward trend is more powerful than the upward trend, and that's why overall we still see a decrease in the trend. But this is not the most appropriate way to visualize a trend, because you can clearly see that this area has a different trend. So it's good to highlight on this area to see the trend, and you clearly see it's a downward trend. And it's good to highlight on this other area to see the trend. You clearly see it's an upward trend. But again, overall, the downward trend is stronger than the upward trend. And that's why you see generally we have this downward trend for the entire visualization or the entire timeline from 2018 to 2008 to 2018. Now we want to do our time series forecasting, right? So we are sure everything is working as well. We have our data, our total crimes. We have our monthly data. If we right click on the plot, we see a forecast. If you click on forecast, you can click now on show forecast. And you see that it automatically calculates the forecast for you based on the patterns it has observed in the data. So it's telling you that the forecast will still be follow an upward trend similar to the upward trend we observed here. So you see this is the forecast it has given you, and you can click on it now and go more details into the forecast. So if you right click again, you go to forecast, you can go to first the forecast options, and you can now start deciding how you want your forecast to be. In this case, let's say it has done for the next 13 months. So it has automatically forecasted for the next 13 months. Let's say let's do just for the next 1 year, right? So we just want the forecast for 2019. We do not want for the next 13 months, just for the forecast of 2019. You can increase it for the next 2 years. You can increase next 3 years, and you see the forecast going. But remember, with the forecast, the further you go, the less accurate the forecast will be, because the forecast, when you go deeper into the future, there is more noise, right? Because the past cannot really determine what's far into the future. So let's do for the next 1 year and leave it at that. And you can go now, it says it will ignore the last data point. It means our data ended in December. This will ignore that December. Sometimes it's important because sometimes the last data, which was the last month's data, may not be reliable enough for you to use as your forecast. But in our case, let's assume it's reliable. So you will say ignore 0. So we want to use our last month's forecast, which is December 2018, within our calculation of our forecast. So we want to ignore last, and we want to show prediction intervals. So this 95th interval percentile is simply, this 95th percentile is simply showing you the probability. So you see that even though it has forecasted this line, it's telling you that the upper interval, it means crime can still, there's a probability, there's a probability that the crime can be as high as this or the crime can be as low as this. So it gives you an interval of the probability of the crime. So even though it gives you its forecast, it also gives you a range of values where the crime, it believes the crime can still fall. That gives you some level of knowledge, right? So that in case you should not think that the crime will just fall within this forecast line. It could fall above the forecast line up to this range and below the forecast line up to this range. So it gives you that interval in which the crime can fall. And that we now have our forecast. Again, you can right click now to interpret your forecast. So if you go to your forecast, you can go to describe the forecast, right? So we went to forecast options. Remember in the forecast options, even the forecast model, we use the automatic. You can decide not to use to a linear model where there is, you see the linear model is just a straight line where it doesn't capture any seasonality. But in our case, let's leave it as automatic. We want Tableau to determine the most suitable model for us. So we want to keep it as automatic. You can also do custom where you decide on what you want. If you want trends, if you have identified trends. And please, this is an assignment. Please go and read what we mean by additive or multiplicative trends, and also go and read what it's meant by additive or multiplicative seasonality. So explore and find out what additive or multiplicative trends mean. So in case you want to use additive trend, or if you want to use multiplicative seasonality, you can decide comfortably which model you want to use, but try to understand what an additive trend looks like and what a multiplicative trend looks like. Also try to understand what an additive seasonality looks like and what a multiplicative seasonality looks like. In our case, let's use the automatic. Let's leave Tableau to actually determine whatever parameters we want to use while we go back and learn about additive trends and additive seasonality. So take that as an assignment. Reach through open ChatGPT, tell them to explain to you what additive trends and additive seasonalities are, and what multiplicative trends and multiplicative seasonalities are, and tell ChatGPT to plot some examples of additive trends or multiplicative trends, additive seasonality or multiplicative seasonality, so that you understand this concept, so that in case you want to use the custom, you actually know how to select the most appropriate parameters based on the insights you are seeing within your historical data. In this case, we'll use automatic, and that is it. So it's okay. So now let's interpret our forecast. So we go to describe forecast. And when we go to describe forecast, it gives you now a summary of our forecast. It tells you our forecast was a month and year data. We clearly saw it was month and year. And it forecasted the next 12 months. It forecasted from January 2019 to December 2019. And to forecast that range, it used historical data from January 2018 to December 2018. No periods were ignored. Remember, we didn't ignore any periods. And the seasonal pattern which the model observed was a monthly season, a yearly seasonal pattern. So every 12-month cycle. So it observed that every 12 months, there is this seasonality. So the way crimes occur in each year is similar. There is maybe an increase, and you can go deeper to look at what happens within each year to see which months have a probability of high crime, which months have a probability of low crime. So it uses a 12-month cycle as its seasonal pattern, and it has used that to calculate its seasonality. Let's go now to the result. So you click, this is summary, you click on models, and again, you have the result. Remember our error metrics, root mean squared error. So please try to understand the results. What is root mean squared error? What is mean absolute error? So this is telling you the results of our model. And you can try different variations and choose the best model where the results, the error is low, right? Yeah, the error is 2,000 crimes out of 50,000 crimes. You know what? MAP, our mean percentage error, it tells you the error is quite good, right? Because it has an error of just 2.4% of error, right, compared to the actual prediction. which is quite good. This is very low, a very low percentage. But try other variations of the model and see which model gives you the best accuracy, the best root mean squared error, the best mean absolute percentage error, and so on. And this is the model. It shows a multiplicative level, a multiplicative trend. That is what Tableau chose. So try other variations, try additive trends or multiplicative trends, try additive seasonality or multiplicative seasonality, and just see and just check the error metrics and go with the model or the parameter that gives you the best error. So this is basically time series forecasting. So as a company now, you can just right click. So if you go now here, you can estimate. So in December, you are estimating a total number of crimes of about 70K in December 2019, whereas in October 2019 you are estimating about 76K of total crime. So this is our forecast. So that said, please, I hope this has been useful. Try to replicate it and try to understand what time and try to interpret your results, interpret your error metrics, and if you have any issues at all, please reach out and I'll be able to help. Thank you and have a nice day.